we will continue our discussion about real numbers. Today, we'll see the third part of real numbers, that is proving the irrational numbers. Correct? So, if you remember children, our first part was discussion of ideal, second part was FTA, and now we move on to the third part, irrational numbers. So, as you can see on the screens now children, irrational numbers are of four types. You're going to write it down in your notebooks. The type 1 is simple root 2, root 3, root 5, root 7, the simple irrational numbers. Type 2 is the combination. Means what? See, if you can see the example, 5 plus root 2. Here, the number 5 is a rational number, you know that, and root 2 is irrational. So, this part becomes the combination of rational and irrational numbers. Type 3 is now two irrational numbers, that is root 2 plus root 7. These kind of numbers, both are irrational numbers. And the last type 4 is when you have a irrational, see 1 upon root 2. So this again becomes an irrational number because a number when divided by irrational number will remain a irrational number. You know that operations on irrational numbers. So we'll continue our discussion on this. So very quickly we'll begin with the first type, that is simple irrational numbers. But before we move on to the first type, before we try to prove the numbers like root 2, root 3 and so on, we will have to look at one theorem which is very important. So the theorem tells us that, if you can read it on your screen, if p is any prime number and p divides a square, okay, now you see here on the board, let me take an example, say 36. Why 36? Because I want a square number. 6 square is 36. Okay, so let us find out the factors of 36. 36, if I find out the factors, 2, 18, 2, 9, 3, 3, 3 and 1. So 2, 2, 3 and 3. These are the prime factors of 36. Means 2 is a factor of 36. So 36, see 36 is written as what? 2 into 2 into 3 into 3. So this 2 is a factor of 36. This 2 is a factor. 3 is also a factor. 3 is also a factor. So this 2 and 3 both are the factors of 36. Now, what does this say? If p divides a square, means if 2 divides 36, means p is a factor. See, it's very important. Huh? You have found this is easy. This is an easy language. We are going to use this statement. P divides a square means what? P is a factor of a square. If 2 is a factor of 6 square, 2 is a factor of 36, 2 must also be a factor of 6, because see, what is 6 actually? 6 was 2 into 3, 3 into 1. So your 6 was 2 into 3. So when it became 6 into 6, 2 into 3, 2 into, means these factors, this 2 into 3, whatever come over here, they actually come from this original number 6. Am I right? So it's very clear, correct? So if p is a factor of a square, means p has to be first a factor of a. So p has to be a factor of a. Example, if 3 is a factor of 6 square, means 3 was first a factor of 6. If 3 was first a factor of 6, then only it could become a factor of 36. It is very simple, very logical thinking it is. If p is a factor of a square, remember this very nicely. P is a factor of a square, p becomes a factor of a. Is this part clear to all of you? So keeping this point of view in mind, we will very quickly move on to our type 1. So now, to prove this number root 2, means this of the form, you can see this of the form root p. Okay, where p is any prime number. Root of any prime is going to be an irrational number. We want to prove root p as an irrational number. We are going to apply the contradiction method, what we had learnt last year. Means what? We want to prove as irrational, we will assume contradictory, we will assume it as rational. Do you understand? जो दिखाना है उसके opposite लेना है. We want to prove as irrational, so we will assume root 2 as rational, And finally, we'll prove that our assumption itself is wrong. Root 2 cannot be rational, and hence our assumption is wrong and root 2 becomes irrational. Now see, children, understand the stepwise solution. Very, very important. You will follow the same steps. You will do it for root 2, we will do it over here. On your own, you will do root 3, root 5, root 7. The question becomes by heart and is going to come into the exam. So it's important. So because first time we are proving, yes or no? So yes, in the solution, let us assume that. We are assuming. Let us assume that root 2 is rational. And if root 2 is rational, how can we express root 2 as? Root 2 can be written as A upon B or P upon Q, where they both are co-prime integers. Very quickly I'll write down the statement over here. So if root 2 is a rational number, we can write root 2 as P upon Q. Our rational number form is P upon Q. See, this is very important, where P and Q are co-prime. Co-prime integers means what? They do not have any common factor. See children, 6 upon 10 is not actually a rational number. What will we reduce it? 2 3s and 2 5s. The original number is 3 upon 5 and 6 upon 10 was the equivalent number. So we are dealing with these kind of numbers, co-prime, which do not have any common factor. So root 2 becomes P upon Q. Now comes the most important step. This is the hint. Squaring on both sides. You can see it on the screen also right now. What are we going to get? On squaring, we are going to get root 2 square. You know that root and square gets cancelled. So root 2 square is 2. 2 becomes P square upon Q square. This Q square is divide. Comes here and becomes multiplied. So see very carefully what is going to happen. 2 into Q square is equal to P square. Now, just understand an example over here. What I am writing. 2 into 5 is equal to 10. What does this mean? 2 is a factor of 10. 5 is a factor of 10. Correct? Come back. 2 into Q square is P square. Means 2 is a factor of P square. Q square is a factor of P square. So I'm going to write over here. I'm going to write therefore 2 is a factor of P square. Very important, our first theorem. If P is a factor of A square, P was going to be a factor of A. So if 2 is a factor of P square, 2 will also be a factor of P. Because if 2 is a factor of P, then and there only 2 can be a factor of P square. So 2 has become a factor of P. Now, if 2 is a factor of P, just now we have said 2 into 5 is equal to 10. 2 is a factor of 10 means 2 into some integer will give me 10. Very nicely understand this. This actually, let this be my equation 1. Let me call this as equation 2. Now if 2 is a factor of P, therefore P can be written as. It's very interesting to understand. Children, understand this very, very nicely. 2 is a factor of 10. 10 can be written as 2 into something, 2 into 5. So 2 is a factor of P. So P can be written as P is equal to 2 into some integer C. Correct? 10 is equal to 2 into some other number 5. So P is equal to 2 into some other integer C. So I am writing here where C is some integer. Correct? And now again we will do the squaring. Why do the squaring? Because we already have a value of P square. So we will find a value of P square over here. So on squaring, what is happening? P square becomes 2 square is 4, C square is C square. P square becomes 4C square. See, this is my equation 1, value of P square. This is equation 3, value of P square. Can we equate the two values of P square? Obviously we can. So we are going to equate the two values of P square. So what do we see over here? 2Q square is equal to 4 because both these are the values of P square. So 2q square is equal to 4c square. This 2 is multiplied, shall go there and become divide. So q square, understand this very carefully, each and every step. Q square is 4c square upon 2. 2 ones are and 2 twos are. Ultimately q square is 2c square. Just p square was 2q square. Q square becomes 2c square. What does this suggest? 2 is a factor of q square. 2 is also a factor of q. Now comes a very important point. See, 2 was a factor of p. 2 has become a factor of q. Means p and q both are going to have a common factor 2. But what we have said, p and q are co-primes and they do not have any common factor. Means here we are saying they don't have any common factor. Here we are proving that p as well as q both are having 2 as a factor. Means we have contradicted ourselves. आपण इकडे जे म्हणलोय त्याच्याचा अपोजिट इकडे प्रूव्ह केलंय. Here we have said they don't have a common factor and now we are showing that p and q both have a common factor 2. म्हणजे हे दोन opposite. Why has this happened? Why has this happened? Because we have assumed itself wrong that root 2 is rational. Assumption itself is wrong. So if root 2 is not rational, means root 2 is irrational number. So very easily we can now see now that we have proved everything, now you see proving for root 3 will become so very easy. See example, suppose we had to prove that root 3 is irrational. What are we going to do? Let us assume that root 3 is rational. So how will we write root 3 as p upon q, where p and q are co-prime integers. Same step, squaring. Most important is this step, squaring on both the sides. Squaring, so root 3 square will become 3. 3 becomes p square upon q square. So 3q square is p square. So 3 is a factor of p square. 3 is a factor of p. If 3 is a factor of p, p will be written as 3c. So p square becomes 9c square. 3q square is 9c square. It goes and divides. So q square becomes 3c square. So 3 is a factor of q square. 3 becomes a factor of q. 3 is a factor of p. 3 is a factor of q. P and q have a common factor 3. Contradicts our assumption. Assumption is contradicted. Number cannot be rational. Very quickly I'll do it for 5 also now. You can see down here. Let us assume that. Suppose we have to prove that root 5. Now you tell me, to prove root 5, let us assume that root 5 is rational. So root 5 can be written as root 5 is equal to p upon q. Squaring. Root 5 square. So root 5 square is 5. So 5q square. So 5 is a factor of p square. 5 is a factor of p. If 5 is p's factor, then p becomes 5c. So p square becomes 25c square. And now from here and here, what are we going to get? We get 5q square is equal to 25c square. Ultimately, what are we going to get? It's the same thing. 25c square upon 5. Q square gives you 5c square. Means 5 is a factor of q square. 5 is a factor of q. 5 is a factor of p. 5 is a factor of q. Contradiction. And that becomes root 5 as irrational number. So this is all about the type 1. Do we understand? Squaring. We are going to prove this p as a factor of this p and q prime number as a factor of a and b. Correct? 5 is a factor of p. 5 is a factor of q. 2 is a factor of p. 2 is a factor of q. 3 is a factor of p. 3 is a factor of q. That's all about the type 1. On the screen, you can see what is the hint. So very quickly, we move on to the type 2, where you can see the question on your screen. Prove that 5 plus root 2 is now. 5 plus root 2 is a combination of rational and irrational. You can see 5 is the rational part, root 2 is This part is very easy. The first statement in every part will always be the same. Let us assume that this is a rational number. So this root 5 plus root 2, if it is a rational, what can the rational number be? Of the form a upon b or p upon q, any form, that doesn't matter. Now this is a very simple thing. I'm sorry, what it was? 5 plus root. Okay, it was 5 plus root 2, doesn't matter. 5 plus root 2. Very simple. The hint also you can see. Just keep the irrational part to the left hand side. Pass on the rational part to the right hand side. Which is the rational part? 5. 5 goes to the RHS. Here it is 5 plus. So 5 goes and becomes minus. Let us see how it happens. So root 2 becomes a upon b minus 5. Just you can cross multiply to make the common denominator. It is a minus 5b upon b root 2. Okay, what is a? Integer. B integer. 5b integer. Integer minus integer. Integer. Integer upon integer. Integer. And what is this whole thing? Integer upon integer. Rational number. Root 2 becomes a rational number. And just now we have proved 2 minutes ago that root 2 is a irrational number. Means because root 2 is a rational, but we already know that root 2 is irrational. Again contradiction. Why contradiction? Because of wrong assumption that 5 plus root 2 is rational. So our assumption is wrong. 5 plus root 2 becomes irrational. Very simple. Let us see. So that's what we can see now. Root 2 was a rational number because a minus 5b upon 5b was rational. But we already know that root 2 is irrational. So this is the statement you're going to write up. I have not written over here, but children, you will write it. So there is a contradiction, and this contradiction has arisen because of our wrong assumption that 5 plus root 2 is rational. Therefore our assumption is wrong, and therefore 5 plus root 2 is irrational number. Very simple part 2, type 2. Simple. You just have to transpose the rational number to the right hand side. Left hand side remains irrational, but right hand side becomes rational, and irrational can never be equal to rational. That is a contradiction. That's all for type 2. Very quickly we move to the type 3. Now in type 2, one was rational, one was irrational. It was very easy. Now both are irrationals. So again the same statement. Let us assume that this is a rational number. If it is a rational number, it will be a upon b, where a and b are co-prime. Now here important, we are going to do squaring. Okay, we are actually going to do squaring on both the sides. So this is a plus b, so we'll be using a plus b the whole square. So very quickly let me do squaring on both sides. Again this is very important. Just as we had done squaring in type 1, now we are doing squaring in type 3. Single irrational, squaring on both sides. Double irrational, squaring on both sides. Squaring on both sides, we get, what do we get? Root 2 plus root 7 the whole square is a square upon b square. A square plus 2ab plus b square. So root 2 square. 2 into root 2 into root 7 plus root 7 square is equal to a square upon b square. Root 2 square is 2 plus 2 root 14 plus 7. Square and square root gets cancelled. Square and square root gets cancelled is equal to a square upon b square. 7 plus 2, 9 plus 2 root 14 is a square upon b square. And now this is which form? It was type number 2. Rational plus irrational. What to do? Transpose the rational part. So first this 9 will go there. A square upon b square minus 9. Correct? We make the common denominator. And this 2 is multiplied. Goes there and becomes divided, because this is also rational. This is also. I need to transpose 9. After that I need to transpose 2. So when we transpose 9, it goes there and becomes minus 9. Making the common denominator a square minus 9b square upon b square. 2 is multiplied, goes and becomes divide. So root 14 has become a square minus 9b square upon 2b square. And again all this is rational. So root 14 becomes rational But we already know that root 14 is irrational. Rational and irrational, contradiction. Why contradiction? Wrong assumption. This is wrong. That means root 2 plus root 7 is irrational. So that's all about type 3. Again, a very easy type. You can see on the screen what this is told. The hint. Again, we have to do squaring on both the sides. Correct? Very nice. Very quickly, the last type, type number 4. What is type number 4? You can see, children, on your screen right now. So this type 4, again a very simple type. It is an irrational denominator. Last year you used to rationalize the denominator. Either you can rationalize or a simple thing. See, let us assume that it is a rational. Again, 1 upon root 5 becomes a upon b. Just take reciprocals on both sides. So what is the reciprocal of this? Root 5. Yes or no? Root 5 becomes what? B upon a. And what is b upon a? Integer upon integer. Root 5 becomes rational. But we already know that root 5 is irrational. Again contradiction. Root 5 is rational. Root 5 is irrational. Why contradiction? Wrong assumption. Our assumption is wrong. 1 upon root 5 is irrational number. Similarly, if you would have got, this was a monomial. If you had a binomial, 1 upon root 2 plus root 7 is equal to a upon b. Again take the reciprocals. So you get root 2 plus root 7 is b upon a. And this now converts into type number 3. Two irrationals. Follow the same procedure, squaring on both sides. Rational becomes irrational, same part. So type 4 is again a derived form of type 3 or type 1. So that's all, children. Type 1, type 2, type 3 and type 4. Very quickly let me revise. Type 1, squaring on both sides. Type 2, transposing the rational part to the right hand side. Type 3, again squaring on both sides. Type 4, taking the reciprocals. So it's very easy. For your homework part, you will try solving the sums from exercise 1.3. So that's all about the third part. Here we finish the third part of our chapter, real numbers. Children, you will write down all these steps and the hints whatever I have given you in the video nicely and carefully, and you can solve the sums on your own. That's all from my side about this proving irrational numbers. Part 3 is over. In our next session, we will deal with part 4, that is the last part, decimal expansions of rational numbers. Till then, thank you all.